In the previous lessons, we learned how to calculate Q equal to MCAT, and Q is heat, and the unit for heat is joule. And Q, or heat, is equal to mass times specific heat capacity for that particular substance. So different substance will have different C times the delta T, and delta is always final minus initial. In order to use this equation, we need to know the unit for each of the variable. Well, Q is heat, and heat is measured in joule. And then M is your mass, which is in grams. And C is your specific heat capacity, which is joule over grams times Celsius. So therefore, this T right here must be in Celsius. And in the process, we also learned that when Q is negative, we know that it is loss in energy. And when Q is positive, it is gaining energy. So it's important to understand if Q is going to be positive or negative based on the problem. And one last thing that we are going to apply in this lesson is that when we have a loss in energy, the amount of energy loss is equal to the amount of energy being gained. That's why we have negative Q equal to positive Q. Now let's apply these two concepts to solve some problem. How many joules are needed to warm? Think about warming. To warm something, you take in energy, right? Okay, to warm 27.0 grams. And this right here would be your mass right there, okay, of copper. And this is the substance, copper. And we know that from 30 degrees Celsius to 85 degrees Celsius. So think of the terminology. From, that would be initial. So this would be your initial temperature right here. And then from to where? Well, in this case, to 85. So that's your final. So don't try to memorize smaller number minus larger number, or larger minus number smaller. Think of the basic English terminology. You're starting from, that's your initial, and ending at your final. And the specific heat of copper is 0.385 joule over gram times Celsius. So this is your C right there, okay? Now let's plug into this equation. Well, it's asking for joule, and joule is represented by the variable Q. So in this case, we are solving for Q, and again, Q is equal to MCAT. And of course, let's plug into the equation right here. So right here, we would have your M right there. Now let's continue. So in this case, can we plug in the values? What's the values for M? That's mass. So that is 27.0. And what is your specific heat capacity, which is 0.385? See, if you know the unit and you know what the variable represents, you just plug it in. And then lastly, your delta T, which is going to be your final 85 minus your initial. In this case, it's 85.0 minus your 30.0. And all you have to do is just plug in here, 27.0, 0.385, and then final, which is 85.0 minus 30.0. And that's it. Now let's plug this into a calculator using parentheses. And notice how I didn't use the multiplication sign, because when you have a number using parentheses, they are multiplied to each other. And this is our answer in joules. And notice how I have two boxes. The first box is your number, and the second box is the unit. And in this case, if you notice, is the system gain or lost energy? Well, this is a positive values, so this means it has gained energy. If it's negative, it will lose energy to the surrounding. So in this case, the system gained energy from the surrounding. Let's try another problem. A sample of lead, its specific heat is 0.138 joule, again over gram times Celsius. Release 2,500 joules when it cooled from 150 degrees Celsius to 20 degrees Celsius. what is the mass of the sample in grams? So this is a hypothetical problem, okay? And again, we are using the same equation again, Q equal to M cat. So Q is equal to MC delta T. And if we look at this problem, we know that we are using the equation Q equal to M cat. In this case, we know the specific heat, that would be your C right there, and release 2500 joule, that would be your what? That would be what? Your Q right there. That's why it's important to memorize the unit for each variable. And lastly, we have a delta T. So again, from, that would be your initial, and then to, that would be your final. And notice how the final values is smaller than your initial. And that's why it's important to visualize what's happening in the problem rather than memorize the pattern. Rather than try to make a pattern like small number minus a large number, or large number minus a smaller number. Read and visualize. So let's plug into the equation. I have release. What does the word release mean? It is negative. So then your Q is equal to negative 2500. And that's why it's important to understand loss in energy is negative, gain in energy is positive. So in this case, it's release, so that means it's negative, and your M is what? Well, in this case, your M is your mass. Well, we are looking for M, and that's why we had to put in M right there. What about your specific heat capacity, which is C? In this case, it is 0.138, okay? And lastly, our delta T. Again, final minus initial, so it's 20.0 minus 150.0. Now, all we have to do is simplify this. Can I simplify this using a Google calculator? Yes, let's plug this in. So let's plug in our calculator to simplify this side. In this case, I'm going to use parentheses again, 0.138. And notice how I use the parentheses again. And this gives me M times negative 17.94. Notice I haven't rounded the number yet. Try to keep 3 decimal places at least. So for this box, determine the sign for Q. Of course, Q is negative because it's release energy. Now let's plug in our answer for the next steps. Well, negative Q, and we know what Q is, so we have negative 2500 equal to M. We are looking for M, so we just put the variable there. 0.138, that is our C, times the delta T, which in this case is 20.0 minus 150.0. And then we have simplified it. This turned out to be 17.94 equal to negative 2500, the same thing before. To solve for this, we have to divide both sides by 17.94. That would simplify equal to 1. If we divide that side by that number, we would do the same thing in this case, negative 17.94. And a negative divided by negative gives us a positive answer, okay? Which makes sense. Our mass is positive. You cannot have a negative mass. So let's plug this into a calculator. Negative 2500 divided by negative 17.94. And our answer is 139.35 grams. So we have 139.35 grams. And that would be our answer. Now let's try one of the most challenging problems. In this case, what would the final temperature if 3000 joules were added to 18.5 grams of water at 22 degrees Celsius? And the specific of water is 4.184 joule over gram times Celsius. And we know right away we have to use Q again, equal to M cat. We don't know if Q is positive or negative. Let's read back. Well, first of all, think about it. It's asking for the final temperature, right? And we know that it is 3000 joule were added. Well, think of the word added. What does that tell you? It is positive. There you go. So Q must be positive. So in this case, Q equal to M is missing right here. And determine the sign for Q, of course, is positive. Well, in this case, let's go back and plug in the values. Well, this is our Q, and it is positive Q, so it's positive 3000 joule. equal to m times c delta t. Well, our m is gram. That's be your mass right there. So we have 18.5 gram. Well, we also know our c as well, which is 4.184. There you go. And notice I didn't plug in the unit because we have a lot of number to work with. The more units, the more number you have is going to confusing us in the long run, okay? So now let's plug in the equation. Well, we know that we are asking for the TF, okay? So TF, because that's the final temperature. So we know a delta is what? It's always final minus initial. Well, if this is in terms of temperature, we have our TF minus TI. So we don't know anything about TF, but we know about TI. It is at 22 degrees Celsius, so 22.0. Now, can we simplify this using our Google calculator? Let's plug this in. Well, I can simplify this side, okay, for sure. And notice how I use parentheses again. And this gives us 77.404. So we have 77.404 times TF minus 22.0. Notice how this is multiplication. So now we can actually divide by 77.404. This would simplify equal to 1. And if we do that side, we would do the same thing to this side. 77.404. And what do we have? And this turned out to be 38.75 or 38.76 equal to TF minus 22 degrees. So now, can we solve for TF? Yes, we plus both sides by 22.0. That equal to 0. And if we do to that side, we got to do to this side as well. Plus 22.0. And what is our TF going to equal to? And our TF is equal to 60.76. And there you go. So let's plug in our answers here. Well, in this case, what we have here is 3,000. And what is missing here? Of course, your M. Well, what is your M in this case? It is 18.5. And what is this? TF minus. And 18.5 times 4.184, that's your C. And then we have multiplied by TF minus what? Well, TF minus TI, which in this case is 22.0. And then over here, we have what? The same values, 3,000 joule. And we have simplified the equation by multiplying these two numbers. We have 77.404. And TF again minus TI, which is 22.0. And we have TF minus your TI, which is 22.0. And lastly, we did the math. Simplify this equation to solve for TF. We have TF equal to 60.76. And there you go.